Hello everyone. Hello everyone. Is my voice audible? Please let me know if my voice is audible. Is my voice audible, everyone? Can you all hear me? So I even want you to just give a confirmation on my display. So I can see people pinging me saying that I'm in the chat window that my voice is clear. And please give a confirmation on the screen. So if it is all ready, we can immediately start on. Just giving a confirmation on the screen. Hope my screen is visible to everyone. I'll just share the first screen of my PPT. So yes, thank you for the confirmation. Very good evening, everyone. So welcome to the second day of your online course of LabVIEW. So we'll just get in depth and we'll just even try to continue whatever we did yesterday, and we'll get a little bit depth on the concepts today. And one thing I just want to mention well in advance, I want you all to just make sure you can subscribe this channel so that you will be able to get a notification for all the other days. So this is going to be a 5 days course in which we are now entering into the day 2. So you people can see all the videos which we are just uploading every day. Fine, great. And the problem is we are facing some issues on sending the links to everyone. So it will be well and good if you people can keep it subscribed, and you will have a video every day, 5 days, continuous 5 days. This is day 2, day 3 is tomorrow, and it keeps going straight. And you people can check it exactly 6 p.m. every day, right? 6 to 7 we'll have this session in continuation of yesterday. I'll just tell you what is today's agenda. Even today we have 2 sections. So section 1 will be looking into creating a temporary variable, in other ways called as a shift register. And we'll also see what is a data flow model in LabVIEW. We'll be trying to understand what is a data flow in LabVIEW. And section 2 will be focusing more on decision making algorithm. So most of your application which is more related to your automation will be badly needing a decision making algorithm. We'll be looking deep into it, how a decision making algorithm can be designed in LabVIEW, right? So for the people, if you have missed yesterday's class, I'm going to quickly tell you what we did yesterday, and you people can also see the yesterday's video available in our channel. So we are going to keep it available for the entire period and even more, so that you people can learn it and even you can practice it using the help of these videos, right? So yesterday we started with basics of LabVIEW. The basics is something but what is the environment of the LabVIEW, what is a front panel, what is a block diagram, what are the palettes available on front panel, what are the palettes available in block diagram. We were just looking into it. There are controls palette, there is a functions palette. We were just looking into them, and we were just moving directly into doing a sum of 2 numbers. We created controls and indicators. Controls are nothing but inputs, indicator nothing but your outputs. We saw these things yesterday, and then we saw the different colors in LabVIEW. We had different colors representing their own data type. We have orange color representing floating point and blue color representing your integers. Then we just saw strings, which is pink color, booleans, which is green in color. Finishing all these basics, we just directly moved into loops. We saw there are 2 different types of loops. We have for loop and while loop. For loop is basically finite loop, where we mention how many number of times the loop is supposed to execute. And then coming back to your while loop, you have a condition terminal where you control it using a boolean data. It need not be always a control from the front panel. It can be a programmatically calculated value. Yesterday I was trying to show you some condition or example where we were just trying to compare the mark. If it is more than 40, it is on or off, something like that. We can try designing an application. Fine. Moving further, I'm just trying to show you what is a shift register. I'll just move into the section 1, creating temporary variable, nothing but your temporary memory, it's nothing but your shift register, right? So where we'll be using shift register is we'll be using them on loops. Fine, we'll be using loops. We saw these loops yesterday, but you were not seeing these black color items yesterday. Am I right? You are not seeing the black color items yesterday because we are going to use them today. So here you can see a for loop and a while loop is having a shift register. So you can ask me what is the necessity of a shift register. So the necessity of shift register falls in iterative data transfer. What is meant by iterative data transfer is So many times when you use a loop, you often need to know the value, or if you want to pass the value from the previous iteration to the current iteration, or maybe from the current iteration you want to push it to the next iteration. So to do this, we'll use a shift register. A shift register helps you to transfer a value from one loop iteration to the next. So whatever you generated now can be accessed in the next iteration. Whatever was generated in the previous iteration can be accessed now. So by this mean, what I can do is I can have current iteration data and previous iteration data together, and I can make sure I can do some algorithms basically, right? So if you see my loop at the bottom, there's a simple example I've just shown you, right? There's a simple example. You can see the loop is iterating 2 times, right? You can see the n values wired with a value 2, which means that the loop is going to iterate 2 times, and it is a for loop. Hopefully I can see that many people would understand that, I mean, this is a for loop. You can see the loop is iterating 2 times, right? So you can see there is 2 pair of shift registers. Many people think there are 2 shift registers here. Not really. There is 1 pair of shift register. There is a left hand side shift register and a right hand side shift register. You have 2 shift registers. Fine. What are these shift registers doing really is nothing but these are all memory elements. These are all memory elements. So what they do is they store value for one iteration. That's the job of a shift register, right? How they do it is, this is a memory element. They start with 0. When the loop executes in the beginning, in the very first time when the loop is executing, this memory is empty. So it starts with 0. So what happens is the value 0 passes from here, and the 2 here is passing from here. The constant 2 is wired to your add operator. So you added 0 plus 2, the output will be 2, right? So this will be the output on the first iteration. Yes. So you can see that the right hand side shift register takes the current data, and whatever was passed on the right hand side shift register will automatically come from the left hand side shift register on the next iteration. So by this mean, what happens is you will be accessing the previous iteration data from the left hand side shift register. Your current data will be passed here, and your previous iteration data will be available here. Fine. So what I'll do is I'm going to get directly into a demo of your shift register. I'll quickly take a LabVIEW window, file, new VI. This is how we create a new VI. I press Control T. We saw this yesterday. Control T will tile up your windows side by side. So I'm going to quickly create a for loop. How am I doing this? I'm coming to the block diagram, right clicking on the block diagram. I go to structures. I have for loop, right? So I drag a for loop like this. And I'm supposed to say how many times the loop is supposed to execute. Let me say I want this loop to execute, for example, 3 times, right? So I'm just saying my loop is supposed to execute for 3 times. Fine. Now I'm going to show you how to create a shift register. Please watch closely. I'm going to show you how to create a shift register. By default, when you create a for loop or a while loop, you will not be having a shift register. And since I'm just showing a demo with a for loop, it doesn't mean that you can't use a shift register in a while loop. You can also use a shift register in a while loop. It is basically for a loop which iterates many times. You can use a shift register to pass it from one iteration to another one, right? So what I'll do is I'll right click on the frame. Just watch here. I'll right click on the frame of the for loop, and I just say add shift register. When I do this, you can see a pair of shift register is being created. So it is not like 2 shift registers are created. No, it is a pair of shift register where this is going to act as an entry and this is going to act as an exit. Fine. So you can see both the shift registers are placed inside the loop. They are going to iterate many times. Anything inside the loop will iterate many times, right? I was telling you yesterday. So the shift registers are created inside the for loop. So what happens is anything you pass it here will come from this shift register on the next iteration, right? So I'll just quickly do a simple application like I'll put an addition operator. Then I'll take a constant, let it be a numeric constant, the same thing. I'll just pass it a value 2. I'll connect it from here to here, right? And you can see the color of the shifter is black. When I say black, how you can understand the connection terminal is black. If you see your addition operator, you can see the connection terminals input and output both are in blue in color. It means that it is trying to operate with a integer value, right? So if you see your shift register, it has a connecting terminal black in color. The reason is Right now the shift register doesn't have any data type. It is not configured for any data type, right? So what I'm going to do is, from here when I connect it, you will see that the shift register is converted its data type. Right now the shift register is designed, I told you a shift register is nothing but it is a memory element. So it is now having a memory unit which is going to hold one item, one number of a numeric data type. Right, from here I can pass it like this. Fine. So this is a kind of a feedback system where what happens is, whatever I write it on the right hand side shift register is now fed back here, and I just take it as an input. Output of my addition is coming as an input using a shift register. So what happens is, in the first iteration, let me say this is a free label. Don't get panicking like what is it doing there. It's a free label to make you people understand. First time when the loop execute, what happens? Let me just talk about that. So this will start with 0. Why 0? Because it's a memory unit. Right now nothing is being written into it, so anything is empty. It's a null data. So what is the default data is 0. Null data is 0 here. So it starts with 0, and you know this wire will carry a value 2. The reason why it carries a value 2 is because I have connected a 2 constant here, and it gets added, and what data will be written into my shift register is 2. 0 plus 2 is 2. The wire will get a data 2, and it will be updating my shift register. This is what is going to happen on the first iteration. Right? So on the second iteration, what is going to happen is, on the second, this loop is going to iterate 3 times, right? Second time, what is going to happen is, this value 2, it's being written on the right hand side shift register, will internally move to the left hand side shift register, and this will turn into 2. Before it was 0, the reason is there was no data inside. Now you wrote the data on the right hand side shift register, right? So this acts as an entry, and this acts as an exit. So what happens is, the data 2 comes here, 2 comes here, 2 plus 2 will be 4, a new data returned to your memory will be 4. So this is what happens on the end of the second iteration. So the end of the third iteration and the last iteration, what happens is, this previous value of 4 moves to the left hand side shift register, and this will be 2 here, and the output will be 6. Fine. And I can also create an indicator. Right click, create indicator. I saw many people ask this question yesterday. Controls and indicators should be created on the front panel, but how are you trying to create it from the block diagram? You're absolutely right. That's a good question. I am actually supposed to create an indicator from the block diagram. Right click on, from the front panel. Right click on the front panel, numeric. I have a numeric indicator. This is the actual proper method of creating an indicator. But there is a shortcut that can be allowing you to create it from the block diagram. How I do it is, this terminal, can you see it's a plus mark? When you touch it, it's a hotspot. I told you it's a connecting tool in LabVIEW. Right click on this terminal, create indicator. This will enable me to create an indicator through a shortcut. This is a shortcut method of creating an indicator. So one advantage of doing this is, you don't want to bother about the compatible data type. LabVIEW will create an indicator of its compatible data type. So you can see that this is a blue color item, which means it's an integer. When I right click, create indicator, you can see it is automatically creating a I32 data. It's an integer 32-bit data. Yes. So I'm going to name it as output. Right. I'm going to name it as output. Hope it's visible to everyone. So now when I run this program, if you want, I'll just increase the size. Right. I'm going to highlight this execution so that you people can understand what's happening. So first iteration, this will be empty. I told you, right? I'll delete these things. First iteration, this will be empty. This will be empty. It will be 2 here. The output of 2 comes here. Right? I'm highlighting it so that you can see. I told you what is the highlight execution yesterday. You can animatedly see what is the data flowing in your wires. The ultimate reason highlight execution is available in LabVIEW for debugging purpose. Now, when you get an unexpected data, you design an application expecting some output to come, but when you get an unexpected data, you are supposed to use a highlight execution where it is going to show you lively what is the data flowing in each and every wire. Right? So I'm going to execute once. The loop will iterate 3 times in that. So you can see that 0 and 2. I'm pausing the code. 0 here, 0 here, and 2 here, and the output of 2 is coming here. I'll resume it. 2 and 2, 4. 4 plus 2 is 6. And you can see the loop stop, and in the output is 6 here. Right? So this is how a shift register basically works. And now what I'll do is, I'll take a new VI to show a quick application using a shift register. Now what I want to do is, I'll take a numeric control, right? I'll take a numeric control. Why I need a numeric control is I'm going to use this numeric control for my n value. I'm going to specify how many times my loop is supposed to execute, right? This is a problem usually we face sometimes when you try to create a control from the front panel and then try connecting it here. You can see that closely. You can see a coercion dot. I was talking to you all about a coercion dot. What is a coercion dot? It's nothing but it's trying to do a data conversion. You are connected a DBL to a I32 integer data type. There's a problem. So to avoid this, what you can do is, if you're not sure about what data type and you don't want to, make the changes afterwards, right click on this terminal, create a control. This is a shortcut as I told you. Now you can see automatically it is creating a control of a related data type. So you will not have a correction dot. So I'm going to name it as n, right? On the front panel, I'm going to specify what is my n value. N value is nothing but the number of times the loop is supposed to execute, right? My ultimate goal is nothing but I want an output which says sum of n number. So this application, what I'm trying to do is nothing but my sum of n numbers. This is what I want to create now. The loop I did many times. I'm going to use the loop performance to add the data again and again and again, right? So I'm going to try designing sum of n numbers. And where is n being specified? This is where I specify my n value. I'll just say 10. If I say 10, I want an indicator here which will say sum of the value 10, starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want to show the sum. That's what I'm planning to design right now. So how I'm going to do it is, I'm going to show you now. Just watch here, right? So here, I'm supposed to need inputs right now. For this application, what are the inputs is nothing but 1 to 10 is my inputs, right? So where I get the values 1 to 10 is, I have a shortcut, I have a terminal called as iteration terminal, which gives me a data from 0 to 9. Why 9? It's because the loop is now iterating 10 times, right? Or for simple purpose, I'll just keep it 5. So now the loop will, the iteration will give me a value from 0 to 4, right? 0, 1, 2, 3, 4. These are the values I'm going to get, right? But I want to add 1, 2, 3, 4, 5, not 0, 1, 2, 3, and 4. So to avoid this, what I do is I'm going to use numeric palette increment. We used the add yesterday. I'm going to use the increment. So what happens is, after connecting it like this, so whatever value comes from here is 0 to 1, and this will convert them all into 1 to 5. Right? I'm going to convert it all into 1 to 5. So this is going to give me, just a minute, 1 to 5, right? So 0 to n minus 1 will turn into 1 to n, right? Whatever may be the value I specify, if I say 10, this is going to give me 1 to 10. This will give me 0 to 9, fine? So I have all these data coming one after the another in each iteration. This is the problem I face here right now. First iteration, this loop, I plus 1, no, this is I plus 1 will give me 1, second iteration 2, 3, 4, 5. Now the problem is I want to add them all together. How I'm going to do it is, to add it, we have an add function, am I right? I use add function. So I will connect it from here to here. Fine. And what should be the other terminal? The problem here we have is in other terminal is, we are unable to access the previous iteration data. First iteration, this will be 1 here, am I right? This wire will take a value 1. Right? Second iteration, this 1 disappears and 2 comes here. Then 2 disappears and 3 comes here, right? So to avoid this, what I'm supposed to do is, I'm going to use a shift register. You people can plan to pass this data directly. From here, you can pass this data directly. That can be a good idea of designing this application. I'm planning something different where I'm going to connect the output of the addition directly here. You can pass any data as per your logic. So see, in this LabVIEW application, it's all about the logics which you try to design. What I'm going to do is, I'm going to bring it from here to here. Fine. So I'm going to tell you how this is going to work. I'll just keep this outside like this. Let me say the loop is going to iterate 5 times. The n value is 5. I'm going to say what is going to happen on the first iteration. First time when it executes, this is going to give me 0. This is also going to give me 0. This is going to give me 0 plus 1, which is nothing but 1. So they get added, 0 here and 1 here, they get added, and the output is going to be 1. So at the end of the first iteration, the value 1 will be written on the right hand side shift register. So immediately finishing the first iteration, this moves to the second iteration. What happens in the second iteration? Whatever you passed on this right hand side shift register moves to the left hand side. So this will turn into 1. This will iteration, because the loop is moved to the second iteration, right? I value will turn into 1, and this will turn into 2, and this is going to be 3. So at the end of the second iteration, the value will be 3. Ultimately, what you have done, you have added 1 and 2, right? The first two numbers are added at the end of the second iteration. Now, what I'm going to do is, moving further, if in the third iteration, this data of 3 moves here, this comes here, this turns into 2, and this turns into 3, and this turns into 6, right? So at the end of the fourth iteration, so this 6 comes here, this is turning into 3, this will turn into 4, and this will turn into 10. Fine. And what happens is, on the last iteration, this will turn into 10, this will turn into 5, right? And this will turn into 6, and the output is going to be, sorry, this is going to be 4. I'm sorry. This is going to be 4, this is going to be 5, and this is going to be 15. So ultimately, if you see, what I'm holding on the shift register is nothing but it's an output of each and every iteration. So output of each and every iteration, I'm storing it in the shift register. Why? Because I take it again, add a new data. With a 0, I add the first data, the output of that adding with the second data, output of that adding with the third data, output of that adding with the fourth data, and keeps going in that way, right? So if I want to see the output, I'll right click on this shift register. This is a shortcut. I'm once again using a shortcut. Right click, create indicator. I'm going to name it as output, right? And I'll just increase the size for the visibility purpose for everyone, right? So I'm not highlighting the execution. I told you how it's going to execute. So I'll just quickly run this program. You can see the output directly. It says sum of n number is 15, right? So now I'm going to see, I foresee a problem here. I'm going to tell you what is this. This works paka, there is no problem in this. It's working really fine. So what I'm going to do, try doing is, if I try executing it again, just see here, I'm going to execute it again. When I execute it again, the output says 30. Once again, when I execute it, it says 45. You can see it is jumping. The reason is, see, now let me say I'll just delete all these things. I'll delete all these things for your understanding, the new understanding. The problem, what I'm trying to say is, anytime when I say the value is to be 5 and run this program, it should show 15. But you can see it is jumping. The reason is, in the previous iteration, the previous run, the output of 60 was sent to this wire. 60 was sent to this wire, and the output is being shown a 60 value, right? Next time when you start running, this value of 60, which was stored in the shift register, moves here, and this will start from 60. On the very first time, what happened, when the shift register was empty, it started with 0. But now it starts with the previous output, right? So because of this, what happens is 60 plus 15. Now this, logic is anyways going to add 1 plus 2 plus 3 plus 4 plus 5 with the offset of 60, and it is going to come up with a value 75. So when I run this, you can see it will be 75. So to avoid this, you should reinitialize your shift register. How I'll reinitialize my shift register? I'm going to right click on the left hand side shift register and create a constant. Right click on the left hand side shift register, create a constant. By doing this, what happens is very simple. Anything inside the loop will iterate many times, anything outside the loop will iterate only once. Yes. So what happens is, you can see this 0 executes, passes a value 0. So whatever was on the shift register in the previous execution, exactly speaking, there is a 75 now, because you can see the output of 75 is being saved in the shift register. This will replace 75 with 0. By this, what happens is your shift register gets reinitialized, and then it starts with 0. Start with the addition program. So now you can see any number of times when I run, you can see it is always showing me 15. This method is called as reinitialization of shift register. It's always needed. The reason is, it will always start the execution from the previous output. Whatever you executed right now, once again when you try executing it, it starts from the previous output. So only for that reason, you should always try to use a reinitializing window. Reinitializing the shift register, right? Fine. If you can understand this, what I'll do is, I'll take a new VI. What I'm going to do quickly is, I'm going to show you what is a data flow model. I want to show something about shift register, but I'll come back to it later. The reason is, see, I'll just go with here. Just show you what is the we have just completed the shift register. Moving next, I'm going to show you what is a data flow model, right? So I'm going to show you what is a data flow model. Just watch here. Now let me say I have a add operator. I have two numeric controls, right? I'm going to name it as input 1 and input 2. So I'll connect them like this, right? And I'm going to have a, for example, let me say for any instance, let me say I'm going to have a multiply symbol and I'm going to create a constant. I have some random logic, let me say, and I'm going to create an indicator to this, create indicator, right? So I'm going to name it as output, right? So now the reason why I was designing this is to make you people understand what is a data flow model. So data flow model is nothing but we are going to determine which item in this block diagram, especially block diagram, is going to execute first, then the next, and it keeps going, right? So if you notice here, let me first talk about your multiply function. Let me talk about the multiply function. You can see multiply function depends on two things, right? It has two inputs. It depends on the two inputs. One is nothing but your constant. The another is nothing but your output of your addition operator, right? So until unless addition operator execute and give a data, a multiply function can never execute. This is basically called as a data flow model. Fine. So if you see there is a dependency. When I talk about dependency, it's nothing but your multiply function is, dependent on your addition function, right? If I ask you about the addition function, it is dependent on the two controls I have been creating it. And if I talk about the output, it is being depending on what? It is being depending on all the previous one. Ultimately what happens is it is depending upon the multiply function, which is actually depending upon the addition function. If you ask me about the output, right? Your output is indirectly dependent on your addition function also, right? So if you talk about this constant, this constant is actually is independent. It is not dependent on anything. He can directly give the data. It's like a source material, so you can directly give a data directly to your multiply operator, right? So now in case if I have a copy paste, I'll just copy paste. Now we have two set of codes, right? There are two set of codes, and you can see when I copy paste, as I told you yesterday, you can see there is one more set of controls and indicators on the front panel also. Fine. So let me talk about this multiply function, which is on the second set of code. This multiply function doesn't have anything related to any of these set on the code number 1, right? So here what happens is this multiply function will not wait for any of these items, any of the first set of code. This will be waiting only for this particular item. So a data flow model is nothing but a particular function executes whenever he gets whatever he needs. What I mean is, talking about this multiply function, he is supposed to wait for this addition operator finish execution and this constant to pass him a data. Once these two finishes the task, passing the data to the multiply, this function will not wait for anything else. It will start executing, right? For example, let me say you have a function which has 10 inputs. I repeat, if I say I have a function with 10 inputs, for example, 9 input terminals have passed the data. Maybe one of the input terminal is not passed the data yet. In this case, that particular function will wait until the last data is also available. The reason is for here, if you see, let me say addition has passed the data to the multiply function, but the constant is not yet passed, for example, let me say. So what happens is this multiply function cannot execute because he don't have the enough information to do the process. So he will be waiting for the all required inputs, then he executes, right? And he waits only for his own requirement, not be worried about anything else, right? So in this application also, you will be saying if I give a data, right? And if I run it once, both the codes update parallelly. Both the outputs update parallelly. The reason is this particular output is being manipulated and output is being derived from this input, and this output is getting our data from this input. So they don't have, this output will never wait for these inputs. Same as such, this output will never wait for these inputs. This is basically called as a data flow model. But if you see in the regular, textual programming languages, where you can see there is a sequential execution, even though there is no dependency of the variable being assigned, the first set of code has to execute, goes line by line execution, and anything, even though it is independent, variable is independent, still it has to wait for the previous codes to execute, right? So whereas in LabVIEW, if there is no independency, there is no dependency, it's going to execute immediately whenever the time comes, right? So this is basically is a data flow model. The reason I want you to tell about, I want to tell you about the data flow model is there is a ability of LabVIEW. There is a function in LabVIEW that can even break the data flow model, which we'll be discussing in the upcoming sessions. So I want you to first understand what is a data flow model. And actually speaking, data flow model is an advantage compared to other programming language. There's one advantage. There are many advantages actually for LabVIEW. One advantage is your data flow model. So data flow model allows you to enable the parallelism very easily. So if you see the parallelism in other programming language, it's not that easy. Here you don't want to do anything special to make a code parallelly executing, right? You have to make sure they don't have a dependency. What is the dependency? Wiring them. For example, if I remove this wire, right? If I remove this wire connected from here to here, for example, let me say, now you are creating a dependency. This multiply function is dependent on this set of code. So creating a wire is basically giving you a dependency. Whereas when I put it like this, now the dependency is changed. The multiply function is dependent on your plus addition symbol. That is what it's going to be waiting for, right? So finishing this, I'll just go to the PPT. If this is clear, I'll just go to the PPT. So we finished the shift register and we just moved into data flow parallelism. And then data flow model is nothing but, I'll just quickly read out the slides. It is just determination of the flow of execution. So here what happens is you will understand what function is going to execute when, right? This is some kind of example I was trying to show you. This is a dependency I was trying to show you all, right? Here if you ask me, which is not at all dependent on anybody, is your input 1, input 2 and the constant 25. They're all usually source material. They are completely independent of anything here. They don't want to wait for anything. As soon as you run the program, immediately it takes the data from the front panel and start executing. It doesn't want to wait for any of the remaining functions or plus or your multiply or even the output. It doesn't want to wait for it. Whereas your addition function will execute the second step. Your inputs will be the first one, and then this is going to be your addition, and then the output of this addition goes to the multiply, and then the multiply executes because it has the input from the constant and also from the addition. Then it's going to be your output. This is how your data flow model of LabVIEW basically executes. Fine. So if this is clear, I'll just keep moving. I'm just moving into section 2. So coming back to the section 2, I'm going to talk to you all about design of decision-making algorithms. When I talk about decision-making algorithm, it's nothing but usually understanding a system and comparing it with the thresholds, and the system should understand what is supposed to execute it, which means that you give a lot of option for your application. You give an option for your application in such a way you can either execute this set of code or this or this or this, so that it makes a decision depending upon the the scenario or depending upon their comparisons. It is gonna make sure it is gonna execute one certain code. Now that is basically called as a decision making algorithms. So to do a decision making algorithm in LabVIEW, we use something called as case structure, which I'm going to show you a demo now. So we'll be using a case structure. A case structure is similar to if else, whatever we have been using as a if else or if then else, right? It's going to be the same as that, right? It's going to be exactly same as that. I'll tell you how this basically works. You can see that a case structure, it's more similar to your it is more similar to your loops. It looks like a loop with a frame, an empty frame you can see. But small differences, usually your for loop will have an end terminal, and then you have a I terminal, iteration terminal you have. Whereas coming back to your case structure, you don't have them. Rather, you have a label called as true, and you have a question mark terminal. It is called a case selector terminal. I repeat it, this is called as a case selector terminal who makes the decision. He makes a decision. This is a very important terminal here. He makes a decision. So he will be deciding which function to execute or which certain code to execute. Fine. And what is the color? The color of this terminal is green. A green basically in LabVIEW is Boolean. So this is going to be considering either one of two items to execute, right? So if I show you how this basically works, this frame visibly show you only one window or one sub-diagram, but actually it has two. You have a true frame, and behind it you will also have a false frame, but you will be able to see only one at a time, right? So what happens is either of this executes based on the case selector's decision. Based on the case selector's decision, he can either allow true case to execute or he can allow false case to execute. And what you will be doing is you will be trying to write a certain code in the true frame, and parallelly you'll write a code in the false frame. So what happens is you try to give two set of codes to your case structure, and this case selector terminal decides which one is supposed to execute. And very importantly, you can see on the second point, only one case will execute at a time, not both. Either one of this is going to execute, either true frame or false frame. You know, Boolean can either take true or false, am I right? So if you pass a true value to your case selector terminal, true frame execute, and any code inside the true frame is going to execute. Meanwhile, when you pass a false value to your case selector terminal, the false case is going to execute, and any code inside the false case is going to get executed. Fine. So if you can get this, I'll just quickly move into the demonstration of your case structure using LabVIEW. I'll take a new VI as usual. I always try to start it from the fresh. What I do is I right click, go to structure. I right click on the block diagram, go to structure, because when I talk about decision making algorithm, it has to be on the block diagram. It is a programming part. So I go to my structure. You have been using for loop, while loop. Now we'll just move into your case structure. I'll drag and drop a case structure. This is how a case structure looks like. Right? I was showing even in the my slides. You can see this is how a case structure looks like. If you want, I can just quickly zoom in. I'll just quickly zoom in. You can see this is how a case structure basically look like. It's a frame. You can see there is a true labeled frame, and you can see a green color terminal. You know, a green color terminal. A green color means it is Boolean. A green color means it's a Boolean. So you can see that it can handle two cases. It can be either true case or a false case, which means that this is behaving like a if else. It's exactly behaving like if else, where it has one condition, two cases, and handles the cases based on the condition. Fine. So now what I'm going to do is, for your understanding, I'm going to create a push button. Right. This is a push button. I'm going to connect it directly to my case selector terminal. Right. So now what is going to happen is, if I leave my Boolean to be on, the value true will pass through this wire, and the case selector will get a value true, and it will execute the frame true. Meanwhile, in case if I go for false, the same false will be passing here. Case selector will get a false value, and you can also see when I click on this drop down option, you can see there is one more frame named false, and you can see there is a tick mark. It means that true is the one which is visible to you. It doesn't mean there is no false. The false is there, but it is not visible. If you want to write a program inside a false case, what you do is you come back here, click on the false. Now whatever you're seeing is a false case. Now what happened? The true case is behind the false case. Now you are unable to see that. Right? So you can finish a code in this. You can design a code in the false. Finishing this code, you can go to the true case and design this code, and make sure you execute this program. Depending upon whatever you click here, that particular code is going to execute. As simple as that. Fine. So very quickly, I'll just show you an example. I want to make this real quick. The reason is because I have more demos to you to show. So I'm just going to name it as A, B, and I'm going to have an output indicator, namely C. Right. So he's the one who's going to choose. Right. So he's going to choose. I'll keep it here. He's going to select. I'm going to name him as a select. Right. What I'm planning to do is, I'm going to give some input. Let me say 34 here, 25 here, for example. So when I leave this to be in true, I want these two input to be added, and the output will be a sum of A and B. When I leave this false, I want the difference of A and B on my indicator. I repeated, what I want to do is, when I leave my select to be true, I want the inputs to be added and the sum to be written here. If I leave this false, I want them to get subtracted, and the output of the difference of the data should be passed out here. This is what I'm planning to do. So what I'm going to do is, just watch here. I'll just keep these all aside. I'm going to tell you how to use them. Now, if it is a true case, what I'll do is I'm supposed to add them, am I right? So I'll right click, numeric, take an add function like this. I can move it like this. This is not the right way, but I'm going to tell you what is the right way. This is not the right way. I'm going to show you why it is not the right way also. So I can do the connection, and this is going to really execute, right? So whenever I just leave this true, the true frame executes. And whatever 34 and 25 will automatically pass here. 34 will come from A, 25 will come from B. They get added, and whatever maybe the output is going to be shown in the C. This is going to work. But in case if I move to false case, you can see when I move to the false case, you can see none of the items are available here. Whatever you leave it on the true case will not be accessible on the false case. This is the issue right now I was telling you about. So if you see that these inputs and outputs are common for both the frames, am I right? When you find some item are common that you have to access in both the frames, then your job is to keep them commonly outside like this. I'll move it outside, right? I'll move it outside like this. I'll move this also outside because indicator is also supposed to be kept outside because it has to be accessed by the false case also. But once I do this, you can see there is something created here. Can you see? There is a orange color block being created. Even here, there is orange color block being created. So these are nothing but your tunnels. I repeat, these are nothing but your tunnels. Tunnels are like two types. There is an input tunnel and there is an output tunnel, right? Input tunnel is a guy who brings the data from outside to inside of a structure. A structure is nothing but a case structure I'm talking about, right? So input tunnel brings the data from outside to inside. Even here, this is the input tunnel. It is bringing data from outside to inside because this is a source material. A and B are source material, your inputs. So they pass the data to your add operator. So this is gonna pass the data inside. So this is the input tunnel, and whereas this one is a output tunnel. Whereas this one is going to be an output tunnel where he's going to take the data outside the structure. Fine. So what I'll do is I'm going to the false case. You can see the tunnels are available, but not the code is available, right? So what I'm supposed to do is I'm going to use a subtract in the false case. And very importantly, if you notice, the input terminals are orange in color, whereas the output terminal is block. Like, I mean, this is, you can see it is like a open tunnel. It is like a hollow block. Can you see it's like a hollow block? It is not properly fully colored. Basically, this is an error in LabVIEW. The reason why this is an error is, so in case, let me say, false case is executing. In case, let me say the false case is executing. This tunnel doesn't know what data to be passed outside, right? So you should guide the LabVIEW in such a way that it doesn't stuck anywhere. So even if a true case executes, the tunnel should know what should be passing out. Even if the false case executes, it should know what is the data being should be passing out, right? So you can see that when I connect it from here to here, right click, I'll clean up this wire, it's like a bit messy. Yes, so I'll just connect it from here to here, right? Don't worry about the bendings of the wire, you can directly connect them. It is going to pass the data anyway. You can see still the code is not executable. The reason why the code is not executable is you can see missing assignment to your tunnel, because your case structure is not assigned. I mean, the tunnel of the case structure is not assigned anything in the false case. So you can see that the moment I finish this connection on the false case, now you can see this is a proper tunnel, and you can see the run button is also normal, right? It means that now the code can be executed. So I'll just quickly increase the size for the visibility purpose. Right. So what I'll do is I'll leave this to be in false. I repeat, I'm leaving this to be in false, which means that this select function is going to pass value, the case selector is going to get a false value, and the false case is going to execute, and the data are going to flow 34 here and 25 here, and the output is going to come out here. So when I run this program, you can see the output is 9, right? So in case if I make it true, I can even highlight and show you. That's the best way that you can understand. I'll highlight the execution and show you how it's going to work in the block diagram. You can see the value of 34 flowing here, 25 flowing here, and a value of true flowing here. Sorry, a true value flowing here, and the true case gets selected, and the data will move inside the true frame, and the output will be generated. Just watch here. You can see the inputs being generated. The true frame is executing. The added operation is working, and the output of 59 is being updated here. Right? So you can't see this animation or the live execution if your highlight execution is switched off. You have to switch on the highlight execution so that you can see the data. Fine. So I can run it continuously. So you can see when I switch this, you can see the output being accordingly shown. If I say 47, no, and I say 100 here, right? Immediately it gives me the data accordingly. So this allows me to decide. Here you can see that this Boolean button is deciding which particular case is supposed to be executed. Fine. So if you now ask me, how can I handle this with multiple cases? Now we are handling with only 2 cases. You can see that by default, as soon as I draw a case structure, just watch here, as soon as I draw a case structure, you have either true case or a false case. You don't have any other cases. Now let me say you have an application where you are supposed to handle multiple cases, right? So I'm going to show you how to make this case structure to work for multiple cases, like a switch case. You know, you have been using a switch case in C program, right? So I'm going to show you how can you use this as a kind of a switch case, you know. So I'm going to take a new VI again. So what I'm going to do now is I'm going to take a case structure again, right? I'm going to take a case structure. So again, if you see, you have only two cases. Either a true case can execute or a false case can execute, which I'm not interested in. I want to add some more cases. The problem why it has only true case and false cases, this case selected terminal is a Boolean data type. You can see it is green in color. It means that it can handle either true or false. It's a Boolean data type, am I right? So to avoid this, what I'm going to do is I'm going to take a numeric control. Just watch here. I'll take a numeric control, right? This is orange color data. When I try connecting it, just watch here. Just watch here. When I try connecting it from here to here, you can see, I'll just zoom in. You can see much things changed here. Number one thing changes. You can see your case selected terminal is turned into a blue color. Before it was a green color, which means that it can handle only Boolean data. Now we can see it is converted into a blue color. Blue color means integer. It can handle integer. But the problem here, once again, we have a problem. What is the problem? You have converted a DBL data to a integer data, and you can see there is a correlation dot. Yeah, we can avoid this correlation dot by changing this data type. I'm going to do that. I mean, finishing this anyway. Then you can see that true and false is now converted into zeros and ones. Am I right? Just watch here. You can see it is now converted into zeros and one. And one more changes. You can see something called as default value. And you can see by automatically, 0 is considered as a default case. Before, you'd never seen a default case in a true and false. Right? Why there is a default cases? I'm going to tell you why there is a default case also. Right? So a numeric value can take any number, need not be only 0 and 1 which is being assigned here. You can see you configured your case structure. Automatically the case structure is configured to execute 0th data and the first data. Right? But a numeric on the front panel can have any data. Let me say I have 25, for example. If I try to pass a value 25, here the data 25 will come here and it goes to the case selector 25. And you can see there is no value of 25 to get processed, right? So there is no value of 25 to get processed. Now you see you don't want to 0 and 1. You want this to be working for 25. You can edit it, right? I'm just putting my cursor here and I'm editing it to be 25. Now you can see you can handle 0 and 25. If you want to, 0 to be removed and rather you want something like I want this to be 20. I'm now handling 20 and 25. So any value of 20, you can handle it. If any value of 25, yes, you can handle it. Fine. But if, let me say, if there is any other data which you are not, actually expecting, if you're not expecting a data to come, let me say it was a value 10, you know that you have not configured the value 10. So what happens is it goes search for the list of items available in your case structure, right? So it check whether there is a 10, 10, 10. It's not there, it goes and executes a default case. When it doesn't find the given input for the case selector, if doesn't find it, let me say it was 10, it is not going to find it, it's going to execute the default case, right? Now you can ask me why it is still handling only two cases. It's supposed to handle multiple cases, am I right? Yes, it can handle multiple cases. I'm going to show you how to handle multiple cases into this case structure frame. Just right click on the case structure again. Right click on the, we are doing this before to create a shift register on your loop, am I right? Same as that, right click here. I'm going to say add case after. Right click and say add case after, and if you want to delete some particular item, you can right click on that particular frame and say delete this frame also. I'm going to say add frame after, and I'm going to say, but you can see by default it has taken the next number 25, and then you can see the 26. But if you want to make it your wish, you can change it, right? You can change it, and now you can see you can add n number of information, right? You can add n number of information, and if I have time, I can just quickly show a demo. Right, I can quickly show a demo. Right, I'll just take a new way better. Let me say I have a numeric control. I'm going to name it as Indian rupee. I'm going to do a currency conversion. Let me say I'm just trying to do a currency conversion. I have Indian rupee, and I'm going to show the corresponding currency value on other currencies, currency value I'm going to mention, right? I have one input and one output. I'm just going to quickly change the size, right? I'm going to check how much of Indian rupee is corresponding to a particular item. Fine. So what I'll do is I'm gonna go for a case structure. Just watch here. I'm gonna take a case structure, right? I'm gonna take case structure. If my intention is only two object, I can use a push button like this. I'm going to choose a what is supposed to be executed. I'm going to say if it is true, right? I'll once again use the free label here. If it is true, I want you to convert the Indian rupee into US dollar, for example. If it is false, I wanted to show you a euro data. Convert, your Indian rupee into a euro data. This is what I want to do. Let me say. So what I'll do is I'll take the multiply function. I'll just put the factor euro. If you see, it is gonna be multiplied with a constant. Right click, create constant. The value is gonna be 0.012. This is the value, and I'm gonna count it like this. Fine. I'll just give enough space for the visibility purpose. It's visible now, clear, right? In case if it is true, it's gonna be USD. I'm gonna take a multiply function again. Count it here and right click, create constant, and type the USD value, right? I hope this is right. No, I just checked before coming back here. No issues. So what I'll do is I'll say how much is, I want to check how much is 200 rupees. So if you see, if this is true, now it selects to be a USD. It shows the 200 rupees in USD, and if it is false, it is going to show in euro. Okay, this is what is going to happen. I'll run this. Now it is in false. It means that it is currently showing the euro value of 200 rupees in India. Then if I say true here, it shows the currency value of a USD, the US dollar. Now let me say I want multiple options. Now let me say I want to see how much it is in Australian dollar. Let me say there's a third one I'm going to create. I can't do it with this because it allows only US dollar now to be accessed. It allows me to do only euro dollar, euro value, not dollar, euro value to be accessed. So to avoid this, what I do is I'll delete this. I'm going to take a numerical value. I told you, right? I'm going to take a numerical value, and I'm going to say choose currency. And the name I'm just give for this terminal is choose currency, and I'm going to count it from here to here, right? I'm going to count it from here to here. Fine. So if you feel like there is a correction dot, I want to avoid this correction dot, what you have to do is change the data type. Right click on choose currency, right? Representation. You can choose it, whatever may be the corresponding data type. You can see now the correction dot is completely gone. I showed you how to change the data type yesterday. Right click on a particular object, representation, and choose whatever the data type you really wanted to be using. Fine. So now what happens is, if it is 0, it means that it's going to work with euro. If it is 1, it means that it is going to work with USD. And I'm going to right click, and I can also say duplicate case. When I say duplicate case, it will create a replication of the current frame. You can see this is the frame number 1. It has this information, these codes inside. So I can right click and say duplicate this case. When I do that, what happens is the entire code also copies. Before, what happened is when I say add case after, it creates an empty frame. Am I right? Add case after will create empty frame, and I'll show you how to delete it. Right click on 2 and say delete this case. Right? If you use when you right click on the frame and say duplicate case, value number 2 comes up with this code also. So I'm going to make this as Canadian dollar. Canadian dollar, if I want to make the value of the Canadian dollar will be 0.018. Fine. This is the value of your Canadian dollar. So you can see that I've done for 2 frames. So I'm going to run this continuously. So when I say 0, it is actually showing me the euro. When I say 1, right? When I say 1, it is showing me the data of USD. And when I say 2, it shows me the value of Canadian dollar, right? If you want add more, this is going to be so easy. How we are going to do is, I'm going to right click, add case after, or duplicate this case. I'm going to do Australian dollar. Let me say I want to include Australian dollar for number 3, and the value is going to be 20, right? So when I run this code, and you can see I'm going to change it to 3, it says the value is 4. Now in case if I say the value is going to be 100, The problem here is when I say 100, right, I have not configured anything for the value 100. You can see I'm choosing the value 100 on my choose currency, but I have not configured any value for, in the case selector for the value 100. In these cases, it's going to execute the default case. Here, the default case is euro. It will automatically choose the euro to be showing me, right? But the problem here is by using these kind of numerical controls, the readability of the code is reduced, right? The readability of the code is completely reduced. Because of that reason, maybe usually we don't prefer numerical data type, right? Numerical data type can be avoided or replaced with one more item called as enum. I'm going to show you what is a enum, which gives more readability. What I'm talking about this is, see, when people comes up here, when people comes up to my window and they are supposed to choose, they want to convert it from Indian dollar to a Canadian dollar, but I'm not sure what is the corresponding number. I know programmer knows Canadian dollar is somewhere number 2. When he chooses 2 here, it's going to show me the Canadian dollar value, right? But this is giving me more or less readability. To avoid this, I can use one more item called as a enum. I right click on the front panel. It's a front panel item. I'm going to go for ring and enum. Say third row, first item, ring and enum. Drag and drop a enum. Right, I'm gonna drag and drop enum, and you can see enum is nothing but a blue color data type. What is a blue color data type? It means it is an integer. It means it is a integer. Blue color data type is nothing but an integer, which means that you can disconnect it from here and you can connect it from your enum. Fine, but the problem here is enum is empty right now. You can give a textual data for your enum. Usually numerics will take a numerical data, whereas enum can have a textual data. I'm going to show you how this works. Basically, it's exactly like your month. We usually write, what is the date today? It's going to be 29/4/2020, right? So what is that 4 basically saying? That it means that it is a April month, a complete shutdown, lockdown month, fine. So what I'm going to do is something like that. I'm going to correspond a textual data. April is corresponding 4, am I right? Something like that. I'm going to correspond data. So I'm going to right click on enum, edit items, and I'm going to say what are the items I really want here. Fine, I'm going to say what are the items I really want here. I'm going to insert, and I'm going to say the first item is euro. Can you see when I say euro, the value assigned is 0. You can see whatever the textual data I just try to enter into this enum, you can see it is automatically assigning a numerical value, corresponding numerical value to the particular textual data you're trying to see. So what you see is basically a euro. What is being accessed is basically a number. This gives more readability to your application. So here I'm just saying USD, right? And next it's going to be Canadian dollar, and then it's going to be a Australian dollar, right? So you can just change the names. The full name is not a problem. I'll just say okay. Fine. So I'll just increase the size. So I'm gonna choose, this is going to be my choose currency from now. I don't want this guy anymore. I'll select it and delete it, right? So this is going to be my, I'm going to choose this guy. Can you see when I click on this, you can see the drop down list box. I can choose whatever I want. Either I can use euro, USD, your Canadian dollar or Australian dollar. I'll just connect it from here to here. You can see even your case structure has more readability. You can see euro, USD, Canadian dollar and your Australian dollar. You can see it is taking the textual data, giving more readability for the developer also. But actually what is being accessed here, you can see that when I right click on this enum and say edit items, you'll be able to see the values being assigned. Actually these are the values which is being passed. That's why you can see your wires and even the controls and indicators basically looks like a blue color data, right? So it's basically taking the numerical value, but readability purpose, you can see all the items are in textual data. Fine. Now I'm gonna run continuously. So you can see when I choose euro, you can see the euro value. When I choose USD, you can see the USD value. When I choose Canadian dollar, you can see the Canadian dollar value. And when I choose Australian dollar, you can see the Australian value, right? And one big advantage here is you are restricting the user to choose the data whatever you want. Am I right? You are not allowing the user. See, when he tries to select, right, he can't choose anything beyond this. But when you see a numerical control, you usually use for 0, 1, 2 and 3. When it was a numerical control to choose the currency, it was only 4 data. But a user can give a data beyond that value. Am I right? He can give 5 or 6 or 7, whatever maybe he really wants to give. Whereas a enum will stop him from using it, right? So which means that when you use a enum, a person can only use these 4 data. Am I right? You have only these 4 data. It means that if you have configured all the 4 data, I repeat, you have 4 data in your enum, which is connected to the case select of the case structure, right? So you have configured 4 data. It means that this default is not even needed. Why? Because you have every value of the enum being handled by the case selector, which means that why we need a default? When any data beyond these data is configured comes, you have to use the default case, right? LabVIEW performs the default case. Now you don't even want the default case. This still, since it's a numeric data, we can see there is a default being utilized because it's still a numeric value, right? It's still a numeric value. This is basically a enum data type. I repeat it. This is a enum data type. For your understanding, I'll just make it as enum data type. And with this, I think the time is exactly 1 hour. We'll just stop this session with this. I want you all to just post the queries, whatever you have regarding this total session. And once again, this video is going to be available online. In our channel, so you people can see that video and you can practice. Practice makes a man perfect. We have also shared the link to download the LabVIEW. I wish you people to just try it. Whatever we just try to show, we are leaving it in the channel without deleting it. The reason is we want you people to practice. Take the videos as a reference. Practice these things, right? The more you practice, you get more confidence regarding this developer tool, right? So try to subscribe. The reason why we want you to subscribe is whoever has attended the session today, if you can subscribe, you people can make sure that you get a notification so that you can get notified about tomorrow's video, or whenever we make a video to this channel. We'll do it only to this channel anyway. So whenever we make a video, we don't want to intimate you, you'll be getting it, right? So to make you people updated, we want you to just subscribe so you get a notification. If not, we have to just generate a link and keep sending you people all the link. And the number of people trying to see this video, to see this live streaming is huge, that it's very, literally impossible for us to send each and every people, right? So when you can subscribe, you people can try to share this video links or the channel. You can just try to share it to your friends so that they can also subscribe and even they'll be able to access it, right? And with this, I'll just complete today's session. I'll see you all tomorrow, and all the very best everyone, and have a happy and safe quarantine time. Thank you so much. See you all.